Hello friends, you are watching channel number Collage. This is my sincere effort to help you understand basic mathematics in a simple and easy manner. In this video, we will discuss geometric applications of vectors, in which we will prove important results, properties, theorems in geometry by using vector method. We will write position vectors of various points involved according to the names of the points without any special mention. For example, we will write position vector of point A as A bar, that of point R as R bar, and that of G as G bar, so on and so forth. Result 1 is in two parts. The first part is medians of a triangle are concurrent. In triangle ABC, median AD, median BE and median CF are concurrent, which means they pass through the same point. The second part is the point of concurrency, which is this point, divides each median in the ratio 2:1. So this point divides median AD, BE and CF in the ratio 2:1. The point of concurrency, which is this, is known as a centroid, and it is denoted by G. We have to prove that G divides each of the medians in the ratio 2:1. Triangle with the position vectors of the vertices A bar, B bar, C bar. For median AD, by midpoint formula, we write D bar equals B bar plus C bar by 2. So that will be 2D bar equals B bar plus C bar. There is A bar lacking on the right hand side, so we will add A bar on both the sides and write 2D bar plus A bar equals A bar plus B bar plus C bar. We name this equation 1. On the same lines, for median BE, we write 2E bar plus B bar equals A bar plus B bar plus C bar. For median CF, we write 2F bar plus C bar equals A bar plus B bar plus C bar. We name this equation 3. We will rewrite these three equations. Equation 1, 2, 3. We observe that the right side of these three equations is same. Therefore, their left sides will also be equal. We will divide each of these equations by 3 throughout and write 2D bar plus A bar by 3 equals 2E bar plus B bar by 3 equals 2F bar plus C bar by 3 equals A bar plus B bar plus C bar by 3. But A bar plus B bar plus C bar by 3 is nothing but the position vector of the centroid G bar. Therefore, G bar equals 2D bar plus A bar upon 2 plus 1 means centroid G lies on the median AD and G divides median AD in the ratio 2:1. Same can be said about median BE and CF. Hence, that proves result 1. In result 2, we have to prove that the angle bisectors of a triangle are concurrent, which means they pass through the same point. So we have here triangle ABC, angle bisector AD, angle bisector BE, and angle bisector CF are concurrent, which means they pass through the same point. This is the point. The point of concurrency is known as incenter, and it is denoted by capital I. So this point is incenter I. Before we start to prove result 2, we must first understand the property of angle bisector of a triangle. Let us understand the property of angle bisector of a triangle. So we have triangle ABC here, side opposite to angle A, which is BC. Let side opposite to angle A be X, side opposite to angle B be Y, and side opposite to angle C be Z. The property says that angle bisector cuts the side opposite to the angle in the ratio of the sides of the angle, which means angle bisector AD of angle BAC cuts side BC, which is opposite to angle A, in the ratio Z as to Y, where Z is side AB, Y is side AC. Angle bisector BE cuts side CA, which is opposite to angle B, in the ratio X as to Z, where X is side BC, Z is side BA. And angle bisector CF cuts side AB, which is opposite to angle C, in the ratio Y as to X, where Y is length AC and X is length BC. We have triangle ABC. For angle bisector AD, D cuts side BC in the ratio Z as to Y. Therefore, position vector D bar will be D bar equals ZC bar plus YB bar upon Z plus Y. For angle bisector BE, point E divides CA in the ratio X as to Z. Therefore, position vector E bar will be E bar equals XA bar plus ZC bar upon X plus Z. And for angle bisector CF, F divides side AB in the ratio Y as to X. Therefore, position vector F bar will be F bar equals YB bar plus XA bar upon Y plus X. We have D bar equals ZC bar plus YB bar upon Z plus Y. We will write Z plus Y into D bar equals YB bar plus ZC bar There is xa bar lacking on the right hand side, so we will add xa bar on both left hand side and right hand side. So it will be plus xa bar on the left hand side and xa bar on the right hand side. We will divide both sides by x plus y plus z. Here the right hand side x a bar plus y b bar plus z c bar upon x plus y plus z is the position vector of the incenter I, which is this point, and we denote it by h bar. Therefore, we write h bar equals z plus y d bar plus x a bar divided by z plus y plus x from equation 1, which implies that I divides angle bisector AD, that is the incenter I divides angle bisector AD internally in the ratio z plus y as to x, z plus y as to x. On the similar lines, we can prove that I divides angle bisector BE in the ratio z plus x as to y, and I divides angle bisector CF in the ratio x plus y as to z. Therefore, I is the point of concurrence of angle bisectors AD, PE and CF of triangle ABC. Result 4 says that a quadrilateral ABCD is a parallelogram if and only if its diagonals AC and BD bisect each other. Suppose quadrilateral ABCD is a parallelogram. Therefore, we have AB bar equals DC bar, which we can write as B bar minus A bar equals C bar minus D bar. By rearranging the terms, we will write it as B bar plus D bar equals C bar plus A bar, which will be B bar plus D bar by 2 equals C bar plus A bar by 2. But B bar plus D bar by 2 is nothing but the position vector of the midpoint of the diagonal BD, which is point E, and its position vector is E bar. Similarly, C bar plus A bar by 2 is the position vector of the midpoint of the diagonal AC, which is E, and its position vector will also be E bar. Since the position vector of the midpoint of diagonal BD and AC are one and the same, which is E, therefore we can say that diagonals AC and BD bisect each other at E. We can prove its converse also, which says that if diagonals of a quadrilateral ABCD bisect each other, then it is a parallelogram. Since diagonals AC and BD bisect each other, therefore we can write B bar plus D bar by 2 equals c bar plus a bar by 2, which will be b bar plus d bar equals c bar plus a bar. We will rearrange the terms and write b bar minus a bar equals c bar minus d bar. Now b bar minus a bar is nothing but ab bar and c bar minus d bar is dc bar. Since vectors ab bar equals dc bar, we can say that side AB is parallel side DC and side AB equals side DC, which proves that ABCD is a parallelogram. We will prove result 4, which says that the median of a trapezium, this is trapezium ABCD, EF is the median. It is parallel to the parallel sides of the trapezium. Median EF is parallel to parallel sides AB and DC of this trapezium. In trapezium ABCD, AB is parallel to DC. Therefore, it is sufficient to prove that EF bar is parallel to DC bar. Since AB bar is parallel to DC bar, we write AB bar equals a non-zero scalar multiple M times DC bar. We name this equation 1. Now since E is midpoint of AD, we write E bar equals A bar plus D bar by 2. And since F is midpoint of BC, we write F bar equals B bar plus C bar by 2. So EF bar will be F bar minus E bar. F bar is B bar plus C bar by 2. E bar is A bar plus D bar by 2. By rearranging the terms, we will write EF bar equals B bar minus A bar by 2 plus C bar minus D bar by 2. But B bar minus A bar is AB bar and C bar minus D bar is DC bar. Therefore, EF bar will be AB bar by 2 plus DC bar by 2. We name this equation 2. But from equation 1 we have AB bar equals M times DC bar. So EF bar will be M DC bar, putting M DC bar in place of AB bar by 2 plus DC bar by 2, which will be M plus 1 by 2 times DC bar, which will mean EF bar is parallel to DC bar. So this is trapezium ABCD and median EF bar is parallel to side DC bar. Therefore, we can say that EF bar is parallel to AB bar is parallel to DC bar. Is proved. Now from equation 2, we have EF bar equals AB bar by 2 plus DC bar by 2, which we can write half times AB bar plus DC bar. But since AB bar is parallel to DC bar, we can directly add their magnitudes. Therefore, we write EF equals half times AB plus DC, which is the length of median is half times sum of the lengths of the parallel sides. This statement is proved. In result 5, we have to prove that angle subtended on a semicircle is a right angle. Draw a circle. So this will be semicircle with radius r and center at the origin. Center at the origin. AB is diameter and C is any point on the circle. We have to show that angle ABC equals 90 degrees. Angle ABC is 90 degrees. Since O is origin, mod C bar will be R. Also, mod A bar will be equal to mod B bar will be equal to R each. And B bar equals minus A bar because B bar and A bar are oppositely directed. From the figure, consider CA bar dot CB bar, which will be A bar minus C bar dot B bar minus C bar. But B bar is minus A bar. Therefore, in place of B bar, we will put minus A bar. It will be minus times A bar minus C bar dot A bar plus C bar, which will be minus A squared minus C squared. But A equals C equals R. Therefore, CA bar dot CB bar will be minus R square minus R square, which will be 0. Since CA bar dot CB bar is 0, we conclude that CA bar is perpendicular CB bar. Therefore, angle subtended on a semicircle is a right angle. In result 6, we will show altitudes of a triangle are concurrent. In triangle ABC, altitude AD, altitude PE, and altitude CF pass through the same point P, known as orthocenter. We will use the strategy that since altitudes BE and CF intersect in point P, all we need to show is AP bar and AD bar are collinear. That we will start by showing AD bar perpendicular BC bar. In triangle ABC, BP bar is perpendicular AC bar. Therefore, dot product BP bar dot AC bar will be 0. BP bar will be P bar minus B bar. AC bar will be C bar minus A bar, which will be P bar dot C bar minus P bar dot A bar minus B bar dot C bar plus B bar dot A bar equals 0. We name this equation 1. Also, CP bar is perpendicular to AB bar. Therefore, CP bar dot AB bar will be 0. CP bar will be P bar minus C bar. AB bar will be P bar minus A bar equals 0. It will be P bar dot B bar minus P bar dot A bar minus c bar dot b bar plus c bar dot a bar equals 0. We name this equation 2. We will rewrite these two equations and subtract equation number 2 from equation number 1. For that, we will change the signs of the terms of equation number 2. So this plus becomes minus, minus becomes plus, minus becomes plus, and this plus becomes minus. And we get p bar dot c bar minus b bar this will be 0, this will be 0, this will be a bar times b bar minus c bar, which is 0. We will write this b bar minus c bar as c bar minus b bar and change this plus sign to minus sign. We will write this as p bar minus a bar multiplied by c bar minus b bar. P bar minus a bar will be a p bar and c bar minus b bar will be bc bar. So ap bar dot bc bar will be 0, which means that ap bar is perpendicular to bc bar. Therefore, the medians of the triangle are concurrent, and the point of concurrency is P, which we call orthocenter. So this is about applications of vectors to geometry. If you like this video, please click the like button. Share this video with your friends and relatives. Do subscribe this channel to get more videos of this type. Thanks for watching. See you in the next video. Keep watching Number Collage. Thank you.